All right, we have discussed the uniform motion, which is represented by this formula and d equal v times t, where you have the straight line representation of the motions, which means if you find the time, and then that's where the location, and the slope, which is the constant over here. And then to use a formula in the uniform motion with d equals v times t. If you have a start and you will have d accelerating like this, going straight. And so this, what's the difference between these two, A and B, are that the A is starting from 0 and B is starting with a offset, which means y-intercept, which means the starting 60. Now in the accelerated motion, you will have not a straight line, but a quadratic formula with t. So d equal half times a t squared. Now, in our example, we have the acceleration being. Now, here is our exercise. A car starts from rest and speed up with acceleration of 10 meters per second squared. So then our formula for this distance versus time is 1/2 10t squared. So you are asked to calculate, well, what's the location of the car at t equals 0 second, 1 second, 2 second, and 3 second, and 3.5 seconds. So this is nothing but a straight plug in the formula. So at 0, you plug in 0, t equals 0, you get 0. And after 1 second, your t half 10 1 squared, you get 5 meters. All right. But if it's uniform, and next second you don't need to calculate about 10 and 15 and so on. But this time it is accelerated because it's getting faster and faster. So you really have to use this formula. And 2 seconds, you plug in 2 and t2 and 2 squared 4, 10, then you get 20 instead of 10. Right? So now you have 3 seconds, of course. 3 squared is 9 times 10, and divided by 2, you get 45. So 1 second is getting 15 meters more. And of course, 3.5 seconds, you get over 60. So you see, just this exercise, just plug in the formula. You'll find out that for the uniform, for the accelerated motion, it's really this formula instead of d equal at. So now, if you want to sketch a graph of this one, it will look like this. So 0 and 1, these are the time along this. So 20 and second. You put all these 4 points, you go like this. So the last one is 3.5 seconds, you get 61 meters per second. And so then 3 seconds is 45. So it is a curve. I ask you a question. So this is not, whenever you have a acceleration, you will see a curved line, okay, instead of a straight line. Okay, you have instead of a straight line, you get a curved line. So then, so that's it. Okay, and hope this helps. I'll try to go back. So,